this is Ms. Yamasaki. Today we are covering the last section of Chapter 8, 8.6. We are solving number and value problems, digit and coin problems, basically. Today's homework, 8.6, 390, number 1 through 14 all. All right. So let's get started. Now, these seem really confusing at first, but it's really about muscle memory because they're always done the same way, and there's no variation to them. They're always written the same way. Here's how it looks. The sum of two digits is 11. If the digits are reversed, the new number is 27 more than the original. Find the original number. So the first thing we're going to say is, let's say in a two-digit number, right? In a two-digit number, we have to assign values. So let's say X is going to be the tens digit and Y is the ones, okay? So we're just going to assign them a name. X is the tens digit, Y is the... So the original number is really going to look like XY, okay? I want you to write it exactly as I'm writing it here, okay? Maybe pause the recording and write the question down. And then write at least one of these, the whole thing including the problem. So if I were to reverse that number, what would it look like? If I were to reverse those digits, that would be a y-axis, right? Now let's talk about the value of this original number. So if it's, let's just say that the number is 32. Doesn't that mean 3 times 10, because it's in the tens digit, plus 2, okay? Or 45 would be 10 times 4 plus 5, right? Let's go 4 times 10 plus 5, right? That's 45, that's 32. And if I did 56, I'd be doing 5 times the 10 digit plus 6. Okay, well, if I have x, y, wouldn't that value be x times 10 plus y? So wouldn't that become 10x plus y? Okay, so the value of xy is actually what we're going to talk about next, which would be the value. Okay, the value will be 10 times the x plus the y. And if I reverse the value, right, the reverse right here, if I reverse, the value of that would be 10 times y plus x. You're writing everything I'm writing. Now we're ready to start. The sum of two digits is 11. Right away, that's an easy one because we know the sum means to add them. We know the digits are x and y, so all we do is x plus y equals 11. Okay? Everybody should be caught up at this point. X plus y equals 11. I'm going to go back to the PowerPoint. It's a little bit cleaner. Now, right here in this sentence, the second sentence is always talking about the reverse. You have to use the reverse values. So it says reverse is, so we're using this. Oops, let me go a little bit further. Okay, we are using, so the first one was the sum, send it over to the and. Well, there is no and, so we're adding two digits. We've got that equation. That's done, right? Now the second one is reverse value. It's the reverse value. It's this, okay? 10y plus x is equals 27 more than, and it says than, so that means plus 27 over here, the original value. Original value is 10x plus y. And those are your two equations, okay? So we are going to do Again, it's the reverse value, 10 at y plus x, is equals 27 more than original value. So it would be the original value is 10x plus y, and we're going to do plus 27. All right, so these are my two equations. We've got to get one variable alone. You can do this in two ways. We can simplify. I've seen kids simplify this. I just go straight for the substitution. Get one variable alone, but you can simplify that side if you want, and then substitute. So I'm going to get one variable alone. Doesn't matter which one, x or y in the first equation. Let's get the y, so it's 11 minus, and now I'm going to substitute it. Every time I see a y, I'm going to substitute in. So it would be 10 times the quantity of 11 minus x plus x equals 10x plus 11 minus x plus 27. And now we just distribute. I get 110 minus 10x plus x equals 10x plus 11 minus x, or you could combine your like terms. That makes 9x, and that makes 11 and 27 is 38. I'm going to subtract my two x's and combine. You should start seeing a lot of 9x's in this problem. 9 and 18x. And then I have 9x plus 38. I'm just combining my like terms. And so now I'm going to move my x's to one side. I'm going to add 9x to both sides. It cancels this one. And I like to see that cancel line, not scribbled out, but canceled. And then I'm going to subtract 38 from both sides. Now I'm left with 18x equals 72. Divide both sides by 18. And x is equal to 4. So if x equals 4, I go back to the original equation, which really, this equation and this equation are the same. So I'm just going to use that second one. I know that x is 4. Okay, so I go y equals 11 minus 4, so y is equal to 7. And if the original equation was xy, then the original number was xy, then the original number is 447, and that's your answer. Okay? So they said, what was the original number? I'm going to pause it for a minute. Okay, so the point why I like these is that there's no variations on them the way there is with motion problems or coin problems. It's always the same, so it really just takes doing it 2 or 3 times, and then you get the muscle memory for it. All right, so here we go. I like to see, the question was originally, find the original number. I want to see that original number in 2-digit form, 47. All right, so here we go again. Step 1, we identify our unknowns. Let's say x is the tens digit, y is the ones digit. Okay? The original number, and write this stuff down. It will just make it so much easier for you and your muscle memory. So, the sum of the 2 digits is 6. Let's hold off on translating it all. Let's again, the original number, if it's a 2-digit number and x is the tens and y is the ones, remember the original number is xy. And what's the reverse number? Yx. What's the value of the original number? What's the value? 10 times x plus y. And this one is 10 times y plus x. So the first equation is the sum of 2 digits is 6. So I do x plus y equals 6. The second equation is reverse. Remember, we're doing value. What's the reverse value? 10y plus x is equals 36 more than original value. 36 more than, so it's plus 36 on this side, original value, 10x plus y. It's terrible. Let me see. See if I can fix that up a little. So it is x plus y equals 6. And the other equation is reverse value, 10y plus x, that's the reverse value, is equals 36 more than plus 36. Original value, 10x plus y. So I can do, let's subtract y. I get x equals 6 minus y. I'm going to let's substitute that in black. So I'm going to substitute it here. Getting 10y plus 10. I got x alone, right? So now I'm substituting in. Over here is 6 minus y. And here is next to, so I need a parenthesis. 6 minus y. But remember, we still have that plus y. Here's the biggest problem. People forget to bring everything else down. So over here, I end up with 9y plus 6 equals 60 minus 10y plus y plus 36. I always tend to forget a y. So let's combine our like terms here. I've got 9y plus 6 equals 96 minus 9y. Combined these, and I combined these. So I'm adding 9y, I'm adding 9y. We end up with 18y plus 6 equals 96. Okay, I'm going to subtract 6. 18y equals 90. Bring it back up here. So 18y equals 90. So I'm dividing by 18. And y is equal to, I think it's 5. 5. So if y is 5, then when I go back up here, x equals 6 minus 5, x is equal to 1. So it's 1, and the answer becomes, 15 is the original answer, and that's what you put in your number column. All right, let's look at what that looked like on, remember the original value, the reverse value. The same equations, let's see, they probably got y alone, so it's going to be slightly different, but you should still get the same answer. Still 15 is the original number. Now let's go back here. I have seen some kids and I was like, what are they doing? Before they substitute in, I've seen them simplify and get this a little bit cleaner. So move the x's to one side, move the y's, combine the like terms. So subtract 1. I'm going to subtract y from both sides. And then I get 9y. No matter what you do, I don't want any mental math. And then I can plus x equals 10x plus 36. I can subtract x. 9y equals 9x plus 36. And now I can, for the y, I'm doing 9 times 6 minus x. It's a little bit cleaner, right? Because I've just put all the x's in a pile. 9x plus 36. So the simplifying, instead of substituting in here and here, they simplify this original equation and then just simplify for 1y. So now I get 56 minus 9x equals 9x plus 36. 9x plus 9x, getting 18x plus 36. Let's hope I'm getting this right. Minus 36, what am I doing wrong? Plus 9x, right? Minus y would be 9x. Oh, here's what I did. I've already dropped it, so there's more room for error here. Yeah, 9. No, I did it right. So subtract y, and I have the x, and there's a 10x plus 36. So I'm subtracting, I get 9x. I don't know why I'm getting this. All right, I found it. 9 times 6 is 54. Wow, that's my morning foggy brain. So this should have been 54 minus, there we go, 54 minus 36 is 18. There we go. So it was a calculating error. If you're not getting whole number digits, then you did something wrong with these, because these are whole number and x is equal to 1. So once you have that, you substitute y equals 6 minus 1, y equals 5. Make sure you place it in the right order. That's a 5, that's a 1, so the original number is 15. If you have reversed numbers, then you might be using, you might be confusing, like if you end up getting x equals 5 and y equals 1, then one thing that could be happening is right here. That when you're building this, oops, let me go back one. If you ended up getting that the answer is 51, then you're probably putting the original value here. You're probably writing 10x plus y equals the reverse, 10y plus x plus 36. And it's actually, this is wrong, because it's the reverse value is this. If we named our original tens number x, then the reverse value is this. And so you have to place that first. So that's a digit and coin problem. Okay. Let's try the next one on your own. Why don't you pause it? I'm going to pause it, and you guys take a minute and do it. Okay, here we go. Try the next one on your own. Now let's check our work. Calling the x the tens digit, the original number is xy, the reverse number is yx. The original equation is x plus y equals 13. And then the next equation is 10y plus x equals. Now, notice here, you've got to do the reverse value. The reverse value. The new number is equals, so it's 10y plus x equals, now I have 9 less than. If I don't switch that and do plus, if I write, minus 9, if I put the 9 first, I will get this wrong, because it's less 9, really. Is 9 less than, the 9 has to come onto the right, the original value, which would be 10x plus y. We have our two equations. Okay, so I'm going to substitute. Let's substitute in for y. I have to distribute. I'm going to combine my like terms. 10x minus x is 9x. 13 and negative 9 is 4. Again, I'm going to combine like terms. 130 minus 9x equals 9x plus 4, adding 9x to both sides, and x is equal to 7. So if x equals 7, then when I substitute it in over here on the left, I get 6. So my answer is 76. Okay, now we're going on to coin problems. This is great for using our box method. I taught you guys how to do the box method with the coins. And so here we go. I'm going to make the box. So either you use the box or you're identifying your unknowns. I would like you to use the box. If ever you are not using the box, you must identify your unknowns. Right? Say x, what is x, whatever your variables stand for. Okay, so this is amount, nickels and dimes, it's quantity, amount times the units, which is money, is equal to a product. We are comparing nickels and dimes. I'm going to add to get a sum. Okay? Mike has nickels and dimes. If the total is 13 coins, of his 13 coins is $1, how much is each? So the total quantity goes down here. We don't know how many nickels, so we'll call them N. We don't know how many dimes, so we call it D. The value of a nickel is 5 cents. The value of a dime is 10 cents. We multiply across. And then the total money amount goes down here. Okay? And those are our two equations. So we have, now, again, if you do not do this, but I would like you to for the test, I want to see if you learned how to do this, then you should always be identifying your unknowns. Say N equals nickel, D equals dime. So I'm saying outside of the parameters of this class. All right, so here I go. I have N plus D equals 13, and I have 0.05 N plus 0.1 D equals 1. I'm going to clear the tens and multiply everything. I don't like the decimal by 100, right? So I'm going to get 5N plus 10D equals 100, right? Now over here, I'm going to make my dimes the additive inverse. So I will multiply this by negative 10. So negative 10 nickels minus 10 dimes equals negative 130. Now I've set up nicely for elimination method. These are canceling. I like to see the cancellation mark. It's negative 5N equals negative 30. We like negative negative because when you divide a negative by a negative, you end up with a positive, and we get N equals 6. Okay? So if I have 6 nickels, that means nickels plus dimes equals 13. 6 plus D equals 13. Subtract 6. Dimes is equal to 7. I get 7 dimes. 7 dimes and 6 nickels. Now this is one kind of, whenever they have quantity and total dollar amount, total amount of coins and total dollar amount of coins, then I would use the box. Okay? Pause the recording if you need to keep watching. Okay, let's pause the recording if you need to write the problem. Again, I'm noticing 19 total coins, a total dollar amount, so I'm going to use my box. go. I've got this, I'm going here. Amount times dollars is equal to the product. We are comparing dimes and quarters. We know that we have 19 total coins. I'll call this D and this one Q. The value here is 10 cents. The value here is 25 cents. Multiply across. And the total dollar amount is $3.85. So I'm gonna get rid of those decimals. I'm going to multiply by 100. And I get 10D plus 25Q equals 385. I always go with tens up here, and I want to cancel the dimes if possible. So I'm going to multiply by negative 10. So we get negative 10D minus 10Q. Oops. Equals negative 190. Be careful when you're adding and subtracting upwards, so I would use a calculator or rewrite it. Here I'm going to end up with 15Q, 385 minus 190 is 195. Divide both sides by 15. And we end up with quarters is equal to 13. So if we have 13 quarters, then we're doing D plus Q equals 19. Dimes plus 13 equals 19. Subtract 13, subtract 13. And dimes is equal to 6. Right? So I have six dimes and 13 quarters. That's what you're putting in your answer column. All right, let's see. I want to do one problem. That's another coin problem. We do have a ticket problem. It's exactly what we did before. So I'm going to just kind of show it to you. They do use the box here. I just thought the box is easy because we use it universally. We're comparing matinee tickets and regular admission. Matinee is the early show at like noon. Back when I was a kid, they used to charge a cheap rate for the early show. So we've got matinee and regular that we're comparing. It's the amount times the money. To go like that. Okay. I would just do your three-way box as usual. We're adding, going up and down, and it's a sum. Remember, we called this amount times the money is equal to the product. Okay. So we don't know what this is. We'll call it M. We'll call this R. And movie theater sells matinee tickets for $5 and regular admission tickets for $6.50. If 195 tickets were sold for a total revenue of $1,110, so it's 195 tickets. This is a $5 ticket, so it's 5M. This is a $650 ticket, so it's 6.5R. And this is 1,110. So my equations are M plus R equals 195. And I also have 5M plus 6.5R equals 1110. I'm going to multiply this bottom one. I guess I don't have to. I just hate to deal with the decimals. I'll leave it alone. 5M plus 6.5R equals 1110. And here I'm multiplying by negative 5. So that becomes negative 5m minus 5r equals 195 divided by 5 is 39. Wait a second. I meant to do 195 times 5. 975. So that's 975. And it's a negative. So here we go. I'm going to end up with 150r equals 1110 minus 975 is 135. Divide both sides by $1.50. And we get 90. R is equal to 90. So of that, if M, let's go a different color, if M plus R equals 195, and R is equal, M plus R is 90. So if I'm substituting in 90, I'm subtracting 90. Subtracting 90, and M is equal to 105. So we have 105 matinee and 90 regular seats. All right, guys, I gotta go because it's time for me to teach. It's 8:59. Gotta stop the video. Bye.